Imagine waking up 100 years in the future, cities floating in the sky, AI running the world, and humanity exploring distant galaxies. Sounds like science fiction, right? But what if time travel wasn't just a fantasy? What if the secrets to bending time were hidden in physics, waiting to be unlocked? From Einstein's theories to real-world experiments, scientists have uncovered mind-blowing clues that suggest time travel might actually be possible. But how close are we? Is there a way to break the rules of time? Buckle up, because today we're diving deep into the future of time travel. Understanding time travel. Ever wished you could hit rewind on life? Or maybe fast forward to the future? Well, guess what? Time travel might not just be science fiction. It's a real possibility, at least in theory. The laws of physics suggest that time isn't as straightforward as we experience it. It bends, stretches, and even slows down under the right conditions. Mind-blowing, right? It all starts with Einstein's theory of relativity. Unlike the ticking clock on your wall, time itself is flexible. It changes depending on how fast you're moving or how strong gravity is around you. This means that time isn't an absolute universal constant. If you were speeding through space at near the speed of light, time for you would slow down compared to someone on Earth. So, in a way, time travel forward is already happening, just on a very tiny scale. But what about traveling back in time? That's where things get tricky. In theory, certain solutions in Einstein's equations, like wormholes or cosmic strings, suggest it could be possible. However, there's a major roadblock: paradoxes. Imagine going back in time and stopping your grandparents from meeting. Would you even exist? This is the infamous grandfather paradox that makes backward time travel incredibly complicated. Scientists continue to explore theories like wormholes, black holes, and quantum mechanics to crack the mystery of time travel. But for now, while the math hints at the possibility, technology is nowhere near making it a reality. The question isn't just can we travel through time, it's should we? Forward time travel. Here's something wild. Time travel to the future is already happening. Not in a sci-fi movie way, but in real, measurable physics. We're all time travelers, moving 1 second per second. But did you know that with enough speed you could skip years, even centuries, into the future? Thanks to Einstein's special relativity, we know that time slows down for objects moving at extreme speeds. This phenomenon, called time dilation, has been proven with high-speed jets and atomic clocks. Put simply, the faster you move, the slower time ticks for you compared to someone standing still. So, if you were traveling in a spaceship near the speed of light, years could pass for people on Earth, while you'd only experience a few days or weeks. And it doesn't stop there. Gravity also affects time. The stronger the gravitational field, the slower time moves. Astronaut Scott Kelly spent 340 days in space, and when he returned, he was slightly younger than his twin brother, who stayed on Earth. Why? Because Earth's gravity slows time down for him compared to Scott, who was in orbit. This means forward time travel isn't just a theory, it's proven science. The catch? To truly leap into the distant future, we'd need to travel at near light speeds, something far beyond our current technology. But who knows, maybe one day space travelers will return home to find centuries have passed, while they've only aged a few years. So, while backward time travel is full of paradoxes, forward time travel, it's not a matter of if, it's a matter of when. Backward time travel. Alright, let's get to the real mind-bending stuff. Traveling back in time. Imagine stepping into a machine, dialing in a date, and suddenly finding yourself in ancient Egypt, or warning the Titanic before it sinks. Sounds incredible, right? But here's the catch. Backward time travel is way more complicated than moving forward. Physics doesn't outright forbid traveling to the past, but it throws a bunch of challenges our way. The biggest issue? Paradoxes. Ever heard of the grandfather paradox? If you went back and stopped your grandparents from meeting, you'd never be born. But then who traveled back in time in the first place? It's a loop that breaks reality. Some scientists argue that time might fix itself in weird ways, preventing changes that would create contradictions. Others suggest multiple timelines, meaning if you change the past, you'd just create a new alternate universe instead of rewriting your own. So how could we actually go back in time? One idea involves closed time-like curves, predicted in Einstein's equations. These would allow you to loop back in time, but so far we don't know if they could exist in the real world. Another theory, cosmic strings, massive, ultra-dense objects stretching across the universe that might warp space-time enough to allow for time loops. But there's no evidence these strings exist. Then there's the biggest question of all. Even if we figure out how to travel backward in time, should we? If history could be rewritten, would we even recognize our present? The past might be set in stone for a reason, or maybe we just haven't found the right key yet. Wormholes. If you want to time travel like in the movies, you need something better than a DeLorean. Enter wormholes, hypothetical tunnels through space and time. If they exist, they could connect two distant points in the universe, allowing you to step into one end and instantly pop out in the past or future. Sounds too good to be true? Well, it might be. A wormhole, also called an Einstein-Rosen bridge, is basically a shortcut through space-time. Picture space as a sheet of paper. If you fold it and poke a hole through, you create a direct path between 2 points. In theory, if you move one end at near light speed or place it near a supermassive gravitational force, time inside the wormhole could pass differently than outside. This could create a natural time machine, but here's the problem. Keeping a wormhole open is nearly impossible. The moment anything tries to pass through, it collapses faster than you can say, flux capacitor. To stabilize one, you'd need something exotic, literally. Scientists believe a form of negative energy, which we haven't discovered yet, could hold it open. Without that, a wormhole would be more of a cosmic death trap than a time portal. And let's not forget the paradoxes. If wormholes allowed backward time travel, we'd run into the same problems as before. Could you travel back and erase your own existence? Would the universe even allow that? Some scientists think time travel paradoxes might fix themselves through quantum mechanics, meaning any action you take in the past just creates a new timeline rather than affecting your own. So, are wormholes the answer? Maybe. The math works, but the technology is pure science fiction, for now. The real question is, if we ever did find a way to open one, would we be brave enough to step through? Time travel future prospects. So, we've talked about theories, paradoxes, and even wormholes. But here's the real question. How close are we to making time travel a reality? Well, let's just say, don't pack your time machine suitcase just yet. The truth is, while the math behind time travel works, our technology is nowhere near capable of making it happen. First, let's talk about speed. We know that traveling at near light speed slows down time for the traveler. But here's the problem. We don't have anything that can move that fast. Our fastest spacecraft, the Parker Solar Probe, moves at 430,000 miles per hour, but even that is just 0.06% the speed of light. To time travel significantly into the future, we'd need to reach at least 90% of light speed, and right now that's impossible. Then there's the issue of energy. Wormholes? They need negative energy to stay open, and we haven't figured out how to create or harness that yet. Even if we did, stabilizing a wormhole would require insane amounts of energy, far beyond anything we can generate. Think about it. We're still struggling to make nuclear fusion practical, and that's child's play compared to what time travel would demand. And let's not forget gravity. Black holes might hold the key to time manipulation, but good luck getting close to one without being spaghettified. Scientists theorize that extreme gravitational fields slow down time, but harnessing that effect in a controlled way, that's not happening anytime soon. So, is time travel impossible? Not necessarily. Science is always evolving. A few centuries ago, the idea of flying across the world in hours was unthinkable. Now we take it for granted. If we crack the mysteries of quantum mechanics, advanced propulsion, or even exotic matter, who knows what doors might open? One thing's for sure, the future of time travel is uncertain. But hey, maybe some future traveler is watching this right now, laughing at how clueless we were. If that's the case, drop us a hint, will ya? So, is time travel just a dream, or are we closer than we think? While science has given us glimpses of what's possible, the technology is still far behind, but who knows? Maybe in the future someone watching this video will be the one to crack the mystery of time travel. If you enjoyed this deep dive, don't forget to like, share, and subscribe to InnoVision Tech for more mind-blowing tech and science content. Until next time, stay curious, stay futuristic, and keep exploring the unknown. What if I told you that for just 1 second, everything stopped? Not just your clock, not just your phone, but time itself, the entire universe frozen in place. No movement, no sound, no light, just complete stillness. Sounds insane, right? But here's the real question. What would actually happen if time stopped for just 1 second? Would you feel it? Would the world change? Or would we never even know? Stick around. because what you're about to hear will make you question everything you thought you knew about reality. Are you ready to dive into the impossible? Let's find out. The nature of time and perception. Imagine if time suddenly stopped, just for a single second. Sounds harmless, right? But hold on, because time isn't just a ticking clock. It's the very thing that keeps reality in motion. From the way we breathe to the way light travels, everything is governed by time. But what if, for a brief moment, time completely froze? Would we even notice it? Well, here's the crazy part. You wouldn't. Your brain, like everything else, relies on time to function. Every thought, every memory, every movement you make depends on time moving forward. If time paused, so would your neurons. Your brain wouldn't even get the chance to register that something strange had happened. Imagine blinking, but in that brief moment, everything, your heartbeat, your thoughts, even the air around you, completely stopped. And yet, when time resumed, you'd continue as if nothing had happened. Think about it like a video game freezing for a second due to lag. The game doesn't realize it's frozen, it just picks up where it left off. The same would happen to you. But here's a fun twist. If time stopped, would light stop too? That means, even if your eyes were open, you wouldn't see anything. The entire world would be trapped in absolute darkness for that one frozen second. And if we go deeper, this raises an even wilder question. If time stopped, but you somehow remained aware, would you feel like you were stuck in eternity? 1 second might stretch into an infinite abyss. Spooky, right? Luckily, your brain won't let you experience that. So, in reality, the biggest mystery of all is, did time ever stop before, and if it did, how would we even know? Physical implications of a time freeze. Let's say time halts. You're in the middle of drinking coffee and suddenly, BAM! Time stops. The coffee mid-air freezes, the steam rising from the cup, suspended like an invisible sculpture. But the real question is, what happens on a deeper level? First off, all movement in the universe would come to a standstill. Atoms would stop vibrating, which means heat would cease to exist. Every object from your body to the sun would instantly drop to absolute zero. But here's the twist, you wouldn't feel cold. Why? Because you wouldn't even be able to process the change. Your nerves wouldn't work, your brain wouldn't function, and even your very thoughts would be put on hold. Then, there's light. Light moves at 299,792,458 meters per second. But if time stopped, light wouldn't move at all. That means the entire universe would be trapped in absolute darkness. Even if the sun was shining, its rays wouldn't reach your eyes until time resumed. Imagine someone flipping a switch and shutting off all light instantly. Except in this case, it's not just the lights in your room, it's every photon in existence. And here's where it gets weirder. What about air? Normally, air molecules zip around, allowing you to breathe. But if time froze, they'd stop moving too. That means for that 1 second, oxygen wouldn't reach your lungs, but don't panic. You wouldn't suffocate because, well, your lungs wouldn't be working either. Time would unfreeze, and you'd continue as if nothing happened. So, the next time you take a deep breath, look at the sky, or feel warmth on your skin, just remember, time is what makes it all possible. And if it ever stopped, even for just a second, the entire universe would hold its breath with you. Biological effects on living organisms. Let's talk about life itself. Your heart, your breath, your very existence. Everything in your body depends on time moving forward. But what happens if time stops for just 1 second? Would you feel it? Would it harm you? Here's the surprising answer: no, you wouldn't feel a thing. That's because the biological processes inside you are just as tied to time as everything else. Your heart beats, your blood flows, and your cells divide. All of these depend on time's steady movement. If time stops, so do you. It's like hitting the pause button on a movie. Nothing changes, but nothing moves either. Your body would be frozen in place, your brain would stop thinking, and even your sense of awareness would be suspended. And here's the freaky part. If everything about you stopped, you wouldn't even know time had paused in the first place. Your body wouldn't age, your cells wouldn't decay, and technically you wouldn't even be alive in that moment, but once time resumes, your body picks up right where it left off, as if nothing ever happened. But here's where things get really strange. Imagine you're blinking right when time stops. Your eyelids would freeze mid-motion, leaving your vision locked in place. If you were walking, your muscles would be frozen in action, defying physics for just a split second. And what about people in mid-sneeze? Would they be stuck with the world's longest ah-chew? The truth is, time's flow is what keeps all living things functioning. If time ever stopped, even briefly, life itself would hold its breath, waiting for the next second to arrive. And yet, because we experience time so seamlessly, we'll never know if it's already happened before. Technological and mechanical consequences. Now let's talk about the world around us. Machines, vehicles, the internet, and all the technology we rely on daily. If time stopped, would your phone glitch? Would planes fall from the sky? Would your favorite video game freeze mid-frame? The short answer, yes, but only for that brief second. Every piece of technology we use operates based on time. Clocks tick forward, computers process data, and electricity flows through circuits. All of it requires time to function, so if time stopped, everything electronic would pause too. Your phone screen would freeze mid-scroll, your Wi-Fi would halt, and even the electrical signals running through power lines would be suspended. Now, here's a mind-blowing thought. Cars, planes, and trains all rely on movement through time. If time stops, a speeding car wouldn't crash, because it wouldn't be moving at all in that moment. A plane in midair would hang in place, defying gravity for that 1 second. The entire world would be a frozen snapshot, paused in perfect stillness. And what about artificial intelligence? Could a supercomputer realize that time had paused? Not a chance. Just like our brains, AI needs time to process information. If time stops, it stops thinking too. It wouldn't detect the pause because in its reality there was no pause. The moment time resumes, it continues processing as if nothing happened. And here's where it gets even wilder. Would digital timekeeping devices skip a second, or would they stay perfectly accurate? Since they rely on electrical pulses that measure time, a 1-second stop might throw them off ever so slightly. But in a world where time is back on track, who would even notice? So the next time your computer lags or your phone screen freezes for a second, just ask yourself, what if time actually did stop for a second and we all just missed it? Psychological and philosophical considerations. Alright, let's get deep for a second. If time stops, do we stop existing? Think about it. Our entire experience of reality is tied to time. Every thought, memory, and feeling happens in a sequence. But what if time itself was put on pause? Would we even be aware of it? Here's the trippy part. You wouldn't even realize that time had stopped. Your consciousness, your awareness, your very sense of self would be frozen, just like everything else. It's like someone pressing pause on the universe. The second time resumes, everything picks up where it left off, and you have no clue anything ever happened. It's a bit unsettling, isn't it? Now let's push this even further. What if time has already stopped before? Maybe it pauses for a second every few thousand years and we just don't know it. Maybe right now, time has stopped, and you're frozen in place, unable to perceive the stillness. And the moment it resumes, well, you're right back to reading this sentence as if nothing happened. Then there's the ultimate question. If time stops, does reality still exist? Time and space are deeply connected, meaning if time ceases, does the universe even remain? It's a classic philosophical paradox. Does reality require time to exist, or could the universe just hang in place, waiting to move again? And if we go even crazier, what if time isn't real at all? What if time is just a human-made construct and the universe moves in ways we can't even comprehend? Maybe we're living in a cosmic illusion where time is just an illusion of motion. If that's the case, then stopping time wouldn't just freeze the world. It might break the very foundation of reality itself. 1 second, that's all it would take to change everything. Or maybe it already has. Theoretical physics perspectives. Now let's get scientific, because if anyone can explain what happens when time stops, it's physicists. But here's the kicker. According to physics, time stopping shouldn't even be possible. Time isn't just a background setting, it's woven into the very fabric of the universe, tied to space itself. Stopping time would mean disrupting space-time, which could have insane consequences. For starters, Einstein's theory of relativity tells us that time is relative. It speeds up or slows down depending on gravity and motion. But completely stopping time? That's next level. If time froze, space-time itself would be affected. Would the universe continue existing in a paused state? Would everything collapse into chaos? And let's talk about quantum mechanics, the science of the tiniest particles. On a quantum level, particles are always in motion, constantly shifting and vibrating. If time stopped, these particles would freeze in place. That means no atomic activity, no light movement, no energy transfers, literally nothing happening. It's a complete shutdown of the universe at its most fundamental level. But wait, it gets weirder. Some physicists argue that time is just an illusion. According to certain theories, time isn't something that moves. It's just a way we perceive changes in the universe. If that's true, then stopping time wouldn't actually do anything because there's nothing to stop in the first place. Mind blown yet? So let's sum this up. If time stops everything, energy, motion, thought, light ceases. But since time itself is part of space-time, freezing time might be impossible without breaking reality itself. And if it ever did happen, we wouldn't even know. So the real question is, what if time has already stopped, but we're just living in its resumed state? What if we're part of a cosmic play button being pressed over and over? Maybe time itself is the biggest mystery of all, and we're just along for the ride. And that, my friends, is the mind-bending reality of time. Did time ever stop before? Would we even know? The universe is full of mysteries, and this is just the beginning. If you love diving into mind-blowing theories like this, make sure to hit that subscribe button and turn on notifications so you never miss a video. What do you think would happen if time stopped? Drop your thoughts in the comments. This is InnoVision Tech, and I'll see you in the next one. Imagine a planet so hot that it rains molten iron. Sounds like something out of a science fiction movie, right? But what if I told you that this is actually real? Meet WASP 76b, a distant exoplanet where the unimaginable happens. Have you ever wondered what it would be like to live in a world where metals turn to vapor, only to rain down as liquid iron? Or where the temperature is so extreme that even the toughest materials melt away? Let's dive into this fiery world and explore what makes WASP 76b one of the most mind-blowing planets we've ever discovered. WASP 76b. Let me take you on an incredible journey to a distant corner of the universe, to a planet where the unimaginable becomes reality. Meet WASP 76b, a giant exoplanet about 640 light-years away in the constellation Pisces. Now hold on to your seat because this planet has a feature that will blow your mind. It rains molten iron. Yes, you heard that right, rain made of molten metal. WASP 76b is not like any planet in our solar system, it's an entirely new breed of extreme. Its day side is so intensely hot that it can turn metals like iron into vapor. Think about that for a second. Just the thought of a planet where solid metals become gases is enough to make your head spin. What's even crazier is that this exoplanet's night side is much cooler, and that vaporized iron condenses into droplets, creating what can only be described as a molten iron rainstorm on the cooler side. Isn't that just mind-boggling? When we first discovered this planet, we couldn't have imagined that such extreme conditions existed beyond our own world. This planet is the epitome of a hellish environment, one that challenges everything we thought we knew about the universe and the types of places life could potentially thrive. Ready to dive deeper into this scorching mystery? Let's go! Extreme temperatures. Brace yourselves because the temperature on WASP 76b isn't just hot, it's blistering. On the side facing its star, the temperature soars to a jaw-dropping 2,400 degrees Celsius, which is hotter than the surface of Venus, and even hotter than some parts of the Sun. Imagine a place where metal turns into a vaporous cloud just from the sheer heat. The planet's extreme temperature is a result of its proximity to its host star, making its environment more like an oven than a hospitable place. To put things into perspective, if you were to stand on the day side of WASP 76b, you'd be facing a heat that could easily melt steel, let alone the metal used in construction. This isn't just a casual warm day, this is the kind of heat that would cook anything in an instant. But it doesn't end there. The heat is so intense that it causes elements like iron, magnesium, and silicon to vaporize into gases. These gases then get swept away by the planet's winds carried to the cooler side. The truly fascinating part? That molten metal, which should be solid under normal conditions, becomes part of a strange cosmic weather system. You can't help but marvel at how extreme and wild the universe can get when it pushes the boundaries of temperature to their absolute limits. Tidal locking. Imagine living on a planet where one side is always day and the other side is always night. Welcome to the world of tidal locking, and it's the unique fate of WASP 76b. This exoplanet doesn't spin like Earth does. Instead, it is tidally locked, which means one hemisphere always faces its star, while the other is in complete darkness. Can you imagine what that would be like? On one side, you'd be constantly basking in scorching sunlight, while on the other side, you'd be stuck in eternal darkness, where the temperature plummets to unimaginable lows. This unbalanced division creates two extremes, a blistering hot day side and a freezing cold night side. The lack of rotation gives rise to this severe split, and it's a feature scientists have observed on various exoplanets orbiting distant stars. It's a strange but fascinating phenomenon. The day side of WASP 76b receives an uninterrupted flood of energy from its star, keeping it hot enough to turn metals into vapor. Meanwhile, the night side is deprived of sunlight, causing the temperatures to drop and creating an eerie contrast between the two hemispheres. What's even more mind-blowing is how this tidal locking affects the planet's weather systems. Winds carrying hot gases from the day side sweep across the planet, and they bring all kinds of strange, alien phenomena like molten iron rains. The planet's lack of rotation makes it a place where extremes collide, and that makes it one of the most bizarre worlds we've ever discovered. Could life survive here? Probably not. But it definitely makes you think about how other planets in the universe might function in ways we can barely comprehend. Iron vapor and condensation. Now, let's dive into one of the most jaw-dropping features of WASP 76b, the rain of molten iron. Yeah, you heard that right. This planet has a bizarre weather system where iron vapor is created on its scorching day side, and then it condenses into liquid droplets on the cooler night side. This phenomenon is a result of the extreme temperature differences between the two halves of the planet. The day side of WASP 76b is a hellish furnace where temperatures are so high that metals, particularly iron, are vaporized into gases. Think of it as a metal mist swirling in the air, made possible by the scorching heat. But what happens when this vaporized iron is carried away by the planet's winds and reaches the cooler, dark side? The temperature drops and suddenly, that vapor can't stay in the air. It condenses back into droplets of molten iron. This creates an unbelievable phenomenon, iron rain. Now, if you were somehow able to stand on the cooler side of WASP 76b, you'd find yourself getting drenched by droplets of molten iron, which is a little bit more than just a rainy day. These iron droplets would be sizzling hot and dangerous, turning everything they touch into a fiery molten mess. The wind and weather systems on this planet are responsible for this process, and it's a bizarre kind of rain that defies everything we know about Earth's water cycle. The science behind it is fascinating, and it raises questions about how exoplanetary atmospheres work. Could there be other planets where different metals rain down instead of water? And what does this mean for planets with extreme conditions? The iron rain of WASP 76b is just the tip of the iceberg when it comes to understanding how wild and strange alien weather can get. Discovery and observations. The discovery of WASP 76b's molten iron rain was a breakthrough that expanded our understanding of exoplanets and their extreme environments. In March 2020, astronomers using the European Southern Observatory's Very Large Telescope made an incredible observation. They detected the presence of iron vapor in the atmosphere of WASP 76b. And just like that, we were introduced to a new world, where conditions are so extreme that metals can exist in gaseous form. This was no ordinary discovery. For years, scientists have been exploring exoplanets and trying to understand how different they could be from Earth. While we've come across many unusual worlds, WASP 76b stood out because of its unique and violent weather system. Thanks to the telescope's advanced capabilities, astronomers were able to analyze the planet's atmosphere in unprecedented detail. They found strong signs of vaporized iron and other heavy metals in the atmosphere, an indication that this exoplanet wasn't just hot, it was a place where extreme conditions could produce strange, almost otherworldly phenomena. But the implications of this discovery go beyond just knowing that iron rains on a planet light years away. It opens up new avenues for studying the weather systems of distant planets, their atmospheres, and how they interact with their stars. The ability to observe such detailed phenomena on distant exoplanets gives us a glimpse into what other extreme worlds might be out there, worlds where rain could be made of metals, or where the atmosphere could be filled with strange gases. The discovery of WASP 76b's molten iron rain shows us how little we truly know about the universe, and how much more there is to learn. Significance. The discovery of WASP 76b's molten iron rain is more than just an astronomical curiosity. It holds immense significance for our understanding of exoplanetary science and the conditions that exist beyond our solar system. This planet challenges the very notion of what a habitable world could look like. The extreme temperatures and bizarre weather systems are like nothing we've ever experienced here on Earth. Studying planets like WASP 76b helps us understand the limits of planetary conditions and pushes the boundaries of what we consider possible in terms of extreme environments. Beyond the fascination of molten rain and scorching temperatures, there's a broader implication. It raises questions about the diversity of planets in the universe. If a planet like WASP 76b can exist with such harsh and alien conditions, what other kinds of planets are out there? What's the likelihood that there are other worlds with strange weather systems, and could they support different forms of life, or at least show us new ways of understanding how life might adapt in extreme environments? WASP 76. B's discovery also highlights the incredible advances in telescope technology. Observing iron vapor in the atmosphere of an exoplanet wasn't possible just a few decades ago, but now, with instruments like the Very Large Telescope, we're able to analyze these distant worlds with astonishing detail. This kind of research not only broadens our knowledge of the universe but also shapes the future of space exploration. So, as we continue to look deeper into the cosmos, we're reminded that the universe is vast, full of surprises and far more complex than we ever imagined. And who knows? Maybe this is just one of the many astonishing worlds waiting for us to uncover. So, what do you think? Could we ever encounter a planet as extreme as WASP 76b in our own galaxy? Or are we just scratching the surface of what's out there? Let me know your thoughts in the comments below. If you found this journey through space as fascinating as I did, don't forget to like, share, and subscribe to InnoVision Tech for more mind-blowing discoveries. Thanks for watching, and stay curious about the mysteries of the universe. The Soviet Union was a powerhouse of engineering, creating machines that often seemed to defy logic and imagination. From colossal aircraft to hybrid sea skimmers, their inventions pushed the limits of technology and design. Did you know the Antonov An-225 Maria still holds the record as the largest cargo plane ever built? These machines weren't just tools, they were bold statements of power and innovation. So get ready to uncover the craziest Soviet machines you won't believe actually exist. The Antonov An-225 Maria. The Antonov An-225 Maria is an extraordinary aircraft, often hailed as the heavyweight champion of the skies. Developed in the 1980s by the Soviet Union, its primary mission was to transport the Buran space shuttle, showcasing Soviet engineering prowess. This colossal plane boasts a wingspan longer than a football field, about 88.4 meters, and is powered by 6 massive engines, enabling it to carry an astonishing maximum payload of up to 640 tons. To put that into perspective, it can lift cargo equivalent to a small skyscraper. What truly sets the An-225 apart is its unique design tailored to handle such immense size and weight. It features 32 wheels spread across 6 landing gears, providing stability during takeoff and landing, and a distinctive twin tail to maintain control. This design allows it to transport oversized and heavy cargo that no other plane can manage, including massive turbines, industrial equipment, and even entire trains. Despite its unmatched capabilities, only one An-225 was ever completed, making it a rare and iconic marvel in aviation history. Beyond its technical achievements, the An-225 symbolizes the ambition and ingenuity of Soviet aerospace engineering. Today it continues to captivate aviation enthusiasts worldwide, representing a blend of power, innovation, and the spirit of exploration that defined an era. Its legacy endures as a testament to what human creativity can achieve in the skies. The T-35. The T-35 tank stands out as a unique and formidable machine from the 1930s, embodying Soviet ambition on the battlefield. What makes the T-35 truly remarkable is its 5 turrets, each armed and capable of firing independently. This multi-turret design was revolutionary, allowing the tank to engage multiple targets at once, a concept far ahead of its time. Weighing over 45 tons, the T-35 was essentially a fortress on tracks, built to break through enemy lines with overwhelming firepower. Despite its impressive size and armament, the T-35 had significant drawbacks. Its massive weight made it slow and cumbersome, limiting its mobility on the battlefield. Additionally, the tank suffered from frequent mechanical issues, which reduced its reliability during combat. These weaknesses made it vulnerable, especially against more agile and better armored opponents. Nevertheless, the T-35 remains a fascinating chapter in tank development history. It symbolizes a bold experiment in military engineering, reflecting the Soviet Union's desire to innovate and dominate through sheer firepower and multi-target engagement. While it wasn't a perfect design and saw limited success in actual warfare, the T-35's ambitious concept influenced future tank designs and remains an iconic example of early 20th century armored vehicle innovation. Its legacy is a testament to the era's daring approach to mechanized warfare. The Lund-class Ekranoplan. The Lund-class Ekranoplan is a remarkable hybrid vehicle that blurs the line between aircraft and ship. Designed by the Soviet Union, it operates using the ground effect, a phenomenon where a vehicle flies just meters above the water's surface, gaining lift from the air trapped between the wings and the water. This design allows the Lund to achieve incredible speeds, exceeding 300 miles per hour, which is faster than many conventional ships, and even rivals some aircraft. Powered by 8 jet engines, the Lund was primarily a military asset, built to swiftly transport missiles and troops across bodies of water like the Caspian Sea while evading radar detection. Its ability to skim so close to the water made it difficult to track, offering a strategic advantage. The vehicle's massive size, combined with its speed and low-altitude operation, made it an engineering marvel of its time. Only a handful of Lund-class Ekranoplans were ever constructed, emphasizing its role as a secretive Soviet weapon. Today, it stands as a testament to Soviet innovation and ambition, showcasing a unique approach to military transport that exploited aerodynamic principles in an unconventional way. The Lund remains a fascinating example of Cold War-era technology, symbolizing a daring blend of air and sea capabilities that few other machines have matched. The Buran Space Shuttle. The Buran shuttle was the Soviet Union's ambitious response to the American Space Shuttle program, and it was really distinguished by some unique technological features. Unlike the US shuttle, Buran was capable of fully unmanned flight and automated landings, which is honestly a remarkable achievement that continues to impress aerospace engineers to this day. In 1988, it completed its only orbital mission, circling Earth twice and returning safely without a crew on board. While the Buran's design was influenced by NASA's shuttle, it actually incorporated different engines and onboard systems, reflecting the Soviet approach to space technology. This divergence showcased not only technical innovation, but also a strategic vision that was really tailored to Soviet capabilities and goals. Despite its technological sophistication, the Buran program was short-lived. The collapse of the Soviet Union halted further development and missions, leaving Buran as a symbol of unrealized potential in space exploration. It represents a period of intense competition between superpowers, where advancements pushed the boundaries of what was possible in aerospace engineering. Today, Buran stands as a testament to Soviet ingenuity and the high stakes of the Cold War space race, embodying both the promise and the challenges of that era. Its legacy continues to captivate those interested in Soviet technology and the history of human spaceflight. The VDNKH robot. The VDNKH robot was an early Soviet experiment in humanoid robotics, designed to demonstrate the USSR's technological capabilities during exhibitions. This prototype could perform simple tasks and mimic basic human movements, showcasing robotics technology that was, honestly, pretty advanced for its time. Beyond its mechanical functions, the VDNKH robot symbolized Soviet optimism about the future, reflecting a vision where robots would support humans in industry and everyday life. Though primitive compared to modern robots, the VDNKH robot played a significant role as a stepping stone in robotics history. It combined engineering with theatrical showmanship, capturing the imagination of exhibition audiences and hinting at a future where humans and machines might collaborate closely. This early humanoid robot really exemplified the Soviet Union's drive to innovate and inspire through technology, blending practical demonstration with symbolic hope for progress. Its legacy lies not only in its mechanical design, but also in its cultural impact, representing a time when robotics was emerging as a field full of promise and possibility. The VDNKH robot remains a fascinating piece of Soviet technological history, illustrating how early robotics experiments helped shape ideas about automation and human-machine interaction. This aligns with broader Soviet efforts to push technological boundaries, as seen in other iconic machines like the Antonov An-225 and the Buran shuttle. The MAZ 7907. The MAZ 7907 is an extraordinary Soviet heavy transporter, designed to tackle the most demanding logistical challenges. Measuring as long as a city bus and equipped with 32 wheels, this colossal vehicle was engineered to haul massive rocket components and military equipment across difficult terrain. What sets the MAZ 7907 apart is not just its size, but, honestly, its sophisticated engineering. Each of its wheels can pivot independently, granting it remarkable maneuverability despite its enormous bulk. This capability allows the MAZ 7907 to navigate tight spaces and complex routes that would be impossible for ordinary vehicles of similar size. Its power and mobility make it a true marvel, capable of carrying loads that would crush standard transporters. The vehicle really exemplifies Soviet determination to overcome logistical obstacles with innovative, large-scale engineering solutions. Even decades after its creation, the MAZ 7907 remains one of the largest and most impressive transport vehicles ever built. It stands as a testament to Soviet ingenuity and ambition, reflecting a period when designing machines capable of extraordinary feats was a national priority. This aligns with other iconic Soviet technological achievements like the Antonov An-225 Maria and the Lun-class Ekranoplan, all showcasing a commitment to pushing the boundaries of engineering and transportation. The Caspian Sea Monster. The Caspian Sea Monster, officially known as the KM Ekranoplan, was a secret Soviet ground effect vehicle that amazed the world with its unprecedented size and speed. Measuring over 100 meters in length and weighing nearly 500 tons, it was designed to fly just meters above the water's surface, exploiting the aerodynamic ground effect to achieve remarkable stability and speed. Capable of exceeding 300 miles per hour, it was faster than most naval ships, making it a formidable military transport. Its hybrid nature, neither fully a plane nor a ship, blurred conventional engineering boundaries. This allowed the Caspian Sea Monster to carry heavy military payloads swiftly across the Caspian Sea while evading radar detection by flying extremely low. The vehicle's innovative design combined elements of maritime and aviation technology, creating a unique class of transport that was both stealthy and powerful. Despite its impressive capabilities, the project was eventually abandoned, largely due to changing military priorities and technological challenges. Nonetheless, the Caspian Sea Monster remains a towering symbol of Soviet innovation and secrecy during the Cold War. Today, it stands as one of the most fascinating and mysterious machines ever built, embodying the Soviet Union's daring approach to pushing the limits of technology and redefining what vehicles could achieve. Thanks for watching this deep dive into some of the craziest Soviet machines ever built. If you enjoyed exploring these incredible feats of engineering, don't forget to hit that subscribe button and ring the bell icon so you never miss an InnoVision Tech update. We love hearing from you, so drop a comment below telling us which machine amazed you the most or what tech topics you want us to cover next. Join the InnoVision Tech community, and let's keep uncovering the future of technology together.